Hello, everyone. Thanks for joining us today. And today the speaker is Danila, and he will tell us about the serialization, what it is, what we can use to do serialization in our projects, and how it can help us. As always, you can leave your questions in the chat during our light talk. Danila, please start.
Okay. Hi guys again. So today we will talk about serialization. Next slide. My name is Danila. I'm a senior software engineer at EPAM. So the agenda for today's talk. We will discuss what is serialization, what popular formats are there, and we will try to compare them. And I will try to give you some insights into trade-offs that the authors of these formats had to make. So let's start. What is serialization? It's a process of converting a data into a suitable format for a storage or transmission. So here we have an object with two fields, an integer and string, and we convert it to some bunch of zeros and ones. Where do we need serialization? From the previous slides, well, we need it when we have two servers communicating. It can be in the case when two microservices of our application are communicating, or when our microservice is communicating with a database, or when we are trying to talk to a third-party service. So, as you can understand, every single application nowadays needs some form of serialization because, well, application that doesn't talk to other applications and doesn't talk to the database, I don't know what it can really do. And so what are the most popular formats? The first one is definitely JSON. It stands for JavaScript Object Notation. A lightweight format that is easy to read and write, and especially it can be read by humans. It's easy to parse and generate, so JSON is great. It's the most popular format nowadays, I think. It's supported by all programming languages, and for each programming language, there are many libraries that support it. Let's see the formats of the objects in the JSON. So we have curly brackets that mean the start of the object. Then we have key value pairs that means the fields in our object. So here we have the ID, name, and favorite movies. Favorite movies is a field of type array. Array is marked by square bracket. And inside this array, we have another object, but also we can have here just simple strings or integers. So the format is pretty simple. And today we will compare the formats using these objects. It's like a user with ID 1 with my name, and the favorite movies is an array with one movie, The Lord of the Rings, Return of the King. So I hope you like this movie too. Let's see how we can work with JSON in Java. In Java, there are a lot of libraries that support JSON. To name two, it's Jackson and BSON, like Google library for JSON. And I will show you today Jackson. In my opinion, it's more popular library because it's a default library for the Spring framework. So when you're enabling Spring MVC, for example, to make a web application, by default, all the requests are parsed by the Jackson library. So to work with it, we have to create an object mapper class, instance of this class. And this instance will be used to parse, serialize, and deserialize all the objects. Okay, let's see how we can do it. To serialize an object, we can call a simple method, write value as bytes or as string. If you're working in production, usually you serialize objects as string, but today we will work only with bytes. I will show you a bit later why. And yeah, that's all. Object mapper will handle everything itself. You only have to handle JSON processing exception in case of something goes wrong while the object is processed. And to deserialize the object, you have a simple method, read value, that accepts, yeah, it has a lot of overrides. So you can put here a string, a bytes array, or some stream of data or whatever, and you have to specify to which class you would like to deserialize this object. And that's all. In our case, we will serialize and deserialize two different objects. So here I have an object user with fields ID, name, and favorite movies. And we have a movie with a name and year. Yeah, and we will deserialize this object to another user with the same set of fields. We need it to simulate a situation where we serialize objects in one microservice and deserialize them in another. Let's try to run the example. It creates an object instance of this class, serializes some user. I have a static method that returns the user that I showed you. And we output the serialized user, deserialize, and output it again. So we run it, wait a few seconds. Yeah, and we see a serialized user, and we have the JSON the same as we expected. But it doesn't have spaces or new line characters. Why? Because in fact, we don't need it when we send the JSON from one server to another. We would better like to avoid sending some bytes and like save some space, and so the network call can finish faster. So we remove all the spaces that we can, and we see this object in one line in one string. We have lengths, so this in serialized version of this object takes 121 bytes. Okay, and deserialized version, we see that it is another user with the same fields. So everything works. Okay, let's imagine that we would like to change the object in one of our microservices. So, for example, we remove the field ID in the object that we deserialize. How will it behave? We run it again, and we see an exception. So, yeah, unrecognized field ID, not marked ignorable, blah, blah, blah. So, by default, using JSON, the deserialization will fail if we have some unknown fields. I don't want this behavior right now, so we can configure the object mapper. It can be done very simply. We just call configure, and we have to specialize which property we would like to configure. Deserialization feature dot fail on unknown properties, and we pass here false. So let's run it again, and it works. So as you can see, it's it's very easy to configure object mapper, and it has lots of properties, so you can make it work as you really need it. And yeah, in our case, we don't have an ID field here. And one more change that we will make. Let's add another private integer h field and see how it will behave. So yeah, the h field is set to 0, so it's like a Java default value for integer. The h was not a part of our serialized value, so it wasn't set during the deserialization. So it works. We were able to, let's say, evolve our schema, change the fields of the object without breaking our program. Okay, that's probably it what I wanted to show you for the JSON. Let's discuss pros and cons of this format. The definite benefit is that JSON is easy to read. Also, it's widely supported. As I mentioned, there are a lot of libraries for each programming language that supports the JSON. And in some languages, it's even built into the language itself, like in JavaScript. It's easy to parse and it has great evolvability. But also JSON has a lot of drawbacks. First, data types are quite limited. So we can pass strings, numbers, arrays, objects, but what if I would like to send a date or an image? So yeah, JSON doesn't support binary formats or dates. I cannot do it. JSON lacks extensibility, so I cannot extend it and add data types that I need. It's a disadvantage. It doesn't have schema validation by default. It can be done with some third-party libraries, but it's not a part of the format itself. And the serialized message is quite big. Let's try to calculate the overheads of the JSON format in our case. So here we have a string in the JSON format. What is the payload in this string? We have number one, it's like ID, my ID. It can be fit within 1 byte. Then my name, it's 18 characters, it's 18 bytes. The name of the movie, 41 bytes. And the year when it was released, it doesn't fit in 1 byte, so it will be 2 bytes. So in total, it is 62 bytes. And our actual size of the message was 121 bytes. So it's like 95% overhead in our pretty simple case. For other cases, for example, when we just send a lot of integers, the overhead can be much, much higher, like 300% or even more. So yeah, it's a great disadvantage of JSON in my opinion. Also, JSON doesn't fit databases well. Well, it's not used in databases because it doesn't fit. So let's imagine a situation where we have a file on the disk that belongs to the database, and in this file we have a lot of JSON objects, and we would like to count them. So we read the first character of the file, we see that it's open in bracket, so we have our first object. And then we have to scan all the characters after that until we find the closing curly bracket. So we have to check each character one after another until we find the expected character, and then we can increment our counter by 1. And so then we have to do it again and again. So reading file like that is really, really slow. That's why JSON is not used in the databases. It's like one of the reasons. And yeah, next we will go and discuss how can we, let's say, improve JSON in some particular places. But first, maybe we have some questions, Tatiana?
No, I don't see any questions.
Okay, great. So let's start like improving JSON by addressing this issue with like counting the objects in the file and by extending the data types provided. So what will we get? We will get a BSON. It's a binary JSON, binary encoded serialization format that is used mainly by the MongoDB database. It provides additional data types like binary for sending images, dates, obvious timestamps, and object ID. Object ID is a special data type for like a primary key of the objects in the MongoDB database. And yeah, it allows an efficient and indexing and querying of the documents. Let's see how it works. I will not show you how our object will look like in the BSON because it will be too long. Here we have a simple object, hello world, one key, one value. And how it looks in the BSON. The first 4 bytes are the size of the document. So in our case, it's in base 16, it's 22 bytes. Then we have our field number 1. 02 means that this field is of type string. Then we have a field name, hello, and all the strings here are terminated with the null character. Then we have the value of this field. Here, the first 4 bytes are again the length of the string, so it will be 6 characters long, and it's world and 1 terminating character, so 6 characters total. And finally, we have 00. It's like end of object, so our object has ended. Let's see how we can work with it in Java. Go to BSON serializer. So the BSON is not that popular format. It's much less popular than JSON. So we will work with it using the same object mapper. All what we have to do is to add, when we create an object mapper, we can pass here a factory that will be used to create and read the objects. And we put here the BSON factory. And actually, the other code stays the same. We write value as bytes and read value to another user. Let's change this user back. And if we try to write value as string here, and we can actually change it like that, it will compile, but it will throw an exception on the runtime. Because the BSON is a binary format, so it's not supposed to work with strings. And it throws like not implemented exception when you try to serialize to string. So that's why we are working with bytes today. And our main methods, we create a serializer, we serialize our object, it's like the same object, then we output it and deserialize it back. Let's run it. There is some additional logic to output all the bytes of the serialized value, but it's not that interesting to look at it. So here is the serialized objects. We can see all the strings are there, so like favorite movies, my name, name of the field name, name of the movie, year, but we don't see numbers here. It's because they're hidden in these squares. These squares mean that characters are not printable, and we can see actually their bytes values. So the first 4 bytes, it's x86 in 16 base numbers, it means 134, and it's total length of our object. And here we have /x10, it means that the field is integer, name, ID, and this 01 is my ID, etc. We will not go through all the fields here. As we can see, the actual size of the message grew. We had 121 bytes, and now it's 13 bytes more. Let's just remember about it for now. And we have the deserialized value. Everything works. Hooray. Let's try to change the objects again. We remove the field ID, and it doesn't work. For the same reason why it didn't work before, we have to configure deserialization feature, fail on unknown properties, false. And let's run it again. Oh, it works. And we just ignored the fields that we didn't know about. Okay, and let's add a field age and run it again. Yeah, so it worked exactly like with the JSON. The field age was not serialized, so we just do not deserialize it, and we set the default value here. So it works perfectly. Yeah, that's how you can work with BSON if you need to. Usually when you work with MongoDB database, you don't have to serialize objects by hands. It's done automatically by the MongoDB driver. But if you need it for some other use cases, you can use Object Mapper with a BSON factory. Okay, let's compare BSON and JSON. So first, the encoding. It's UTF-8 for JSON and binary for BSON. Because of it, JSON is human and machine readable, and BSON is only machine readable. We can see what strings are stored in the BSON, but we cannot see the numbers, arrays, etc. BSON supports more data types, for example, date, bin data, so like binary for sending images or whatever, and few others. JSON is fast to read, but a bit slower to build. And BSON is slow to read, but faster to build and scan. So here we can see some advantages in the particular use cases. So the BSON was built for the database, where we need to scan objects faster. So, okay, we can lose some speed while reading, but we just have better scanning speed. And the space, yeah, BSON is slightly larger, in our case, by 13 bytes. If we return to the example with a file with a lot of objects, we can see how the BSON can win here. BSON has a total size of the object, so it can read first four integers, first 4 bytes of the object. It will see the size of the object, and then it can just skip the 22 bytes without reading them. Then it will see, okay, the next object is like, I don't know, 10 kilobytes in size. We don't have to read these 10 kilobytes. We just increment our counter by 1 and skip it and go further. So yeah, for scanning, it's much faster. But for it, we lose some readability and lose some space. Okay, let's try to improve BSON a bit, but maybe before it, we have any questions?
No, I still don't see questions in our chat.
Okay, then I'll think that everything is clear. Okay, so what don't we like about the BSON? Personally, I don't like that it requires too much space. And if we try to understand why it requires so much space, well, it's because we store the names of all fields. And if we, for example, would like to send an integer and the field has like, I don't know, 30 characters long name, we will send 34 bytes instead of 4 bytes. It's like a very big overhead. Let's try to remove the names of the fields from the object. And what we get? MessagePack. It's a binary serialization format that is designed to be more compact and faster than the JSON. It supports a lot of data types, and yeah, it includes features like schemaless data serialization, extensibility, and cross-language support. Let's see it in action in Java. So we open MessagePack. Oops, not this one. Oh my God. It's MessagePack serializer. Okay. So this example has to be run with this JVM flag, otherwise it doesn't work. I will not dig into it, why it requires this flag, but if you will decide to play around with this example, just add it to the VM options. Yeah. So to work with the MessagePack, we create a MessagePack instance, and we can simply call the method write to serialize it to the byte array, and read with passing here byte array and the class that we would like to deserialize into. And that's all. We just have to handle some IO exceptions in case something goes wrong. Okay, yeah, let's change our another user back. So we return the ID field and remove the age. Yeah, and let's see the main method. So it creates the serializer, serializes the object, outputs it, and deserializes it back. So very simple. Let's run it. And it cannot compile. Yeah, this exception, because it's thrown because this flag was not added. And actually, I don't know how to edit without exiting the presentation mode. So I will do it very quickly and return back. Yeah, so it ran successfully. Oh my god. Once again. Yeah, so now it works. We have our serialized message, so we can see all the strings that we stored, like my name, the Lord of the Rings, the Return of the King, and we don't see the names of the fields. Here is the binary representation. I don't understand anything from here, it's okay. And serialized length is 70 bytes. So it's almost twice as efficient as BSON. So it's great. And we deserialized it successfully. ID equals 1, name, favorite movies, everything works. Hooray, we just, well, implemented, used the perfect data format. Let's try to break it a bit. Let's go to another user object and remove the field ID. So now we have one microservice that serializes field ID and another microservice just doesn't read it. What will happen? Yeah, I just remind you that in JSON and BSON, just nothing happens. Uh-oh. And we see an exception. And it says that it expected raw value, like a string, but got an integer. Because we do not store the names of the fields, we cannot understand which fields are present. So when we serialized the value, we put like the integer 1 to the very beginning of the object. And then it was like my name, etc. And then when we deserialize it, we expect to see the string first, but we see integer. So it breaks. And it's not the biggest problem yet. Let's open it back, and let's say that one of our microservices decided to add field age. And what will happen? It works. It doesn't crash, but it should better crash. And we see the deserialized value age equals 1. But it's not the field that I wrote here. I wrote ID1, not H1. It's like another field. And yeah, it's the same problem. We wrote 1 and then my name. And when we read it, we were reading integer age, not integer ID. And we read 1 and we saved it to this field. So the MessagePack seems to be a very small format, so it requires only 70 bytes, but it's really hard to evolve the schema. If you add a field, it may crash. If you remove a field and add the fields of the same type, it will not crash, but it will corrupt your data. So probably it's not ideal too. Yeah, that's all what I wanted to show you about the MessagePack. Let's see some benefits and drawbacks. Benefits: high performance. It's much faster than the JSON and BSON, partially because we don't have to write the names of the fields. Small results in message size. In our case, it was just 70 bytes, so it's pretty good. And it supports a lot of types. Drawbacks. Well, it's not readable, as well as all binary formats. They are not designed to be readable. It's hard to evolve schema without breaking everything, and it's not widely adopted. So yeah, the JSON is much more popular, and there are more libraries for it. They are better tested probably because like there are a lot of projects that are using JSON. So okay, MessagePack is still not the ideal serialization format, and we will try to find another one. And now maybe we have some questions finally.
I still don't see any questions, so I
Okay.
assume everything is we can proceed.
Okay, but before we proceed, we will have like 30-second commercial break. I just remind you guys that we have a free online Java school, MJC.school. It goes from the very, very basics of Java, like how to write a main method, and up to modern frameworks like Spring and Cloud and advanced concept like CI/CD. So if you would like, you can enroll for free on mgc.school. And if you would like to participate as a contributor, feel free to get in touch with us too. Okay, let's go. Let's go back. What was the main problem of the message pack? I think it was not. It was the fact that we couldn't securely evolve the schema. So what if we specify exactly what is the schema that we are serializing to and deserializing from? It will save us from a lot of problems. And here we can see the Protobuf. Protobuf, short for protocol buffers. It's a binary serialization format. It's developed by Google. It's used by Google, supported by Google. And nowadays it's used in many technologies. For example, in gRPC, we will have a light talk on it in a few weeks. Yeah, it's binary, it's very compact, it's language agnostic, it supports a lot of data types, and it provides compile time checks. So let's see how it works. First, we have to specify the format, the schema that we will use. We have this file. We specify the syntax we will be using. It's a Proto 3, not Proto 2, not Proto 1. It's, I think, the latest for now. Then we specify the package. It can be any, and we can specify then the messages. Message is like a class in Java. And here we say the movie with two fields, string name and integer year. Integer 32, it's like a usual Java integer. We can use integer 64, it will be long. So you can just find the mapping of these data types online. And then we have a user with integer ID, string name, and repeated movie, favorite movies. It's like a list of movies or an array of movies. And as you can see here, each field has its number. And we will see why do we need it soon. Okay, let's open the terminal. Let's open the terminal here. Oh my god, I forgot how to open it. Okay, just a second. I will return quite fast. Okay, it's Alt F12. Oh god, I'm sorry. Yeah, so we open the terminal, and now based on this schema, we have to generate the Java classes. We can do it using the Gradle task generate proto. We call it, and some Java classes are being generated. And yeah, it worked. Yeah, we also have another user schema with the same fields, the same as we had with the previous examples. And in order to have this generate proto task, we have to add a Google Protobuf plugin to our Gradle or Maven or whatever you're using. And if we go to Protobuf serialization, oh my god, why doesn't it work? And it does not compile, and it is strange. Yeah, let's see how it works for now. Maybe it will solve a bit later. Here we don't create any. Oh yeah, let's first see what classes Protobuf generated to us for us. Here is the class for our user and movie schema. I hope you can read it fast enough. I will scroll through it a bit faster and a bit more fast. Yeah, so it's 1600 lines of code that is not very readable, and the code is pretty difficult. So in my opinion, it's a disadvantage. It's hard to see what happens here, but the general idea is that you don't have to understand what happens here. These classes are generated, so they can parse to Protobuf, from Protobuf, and you can use just public methods of these classes. Yeah, and again, this class was generated by the Protobuf plugin. I didn't write it. Yeah. To serialize an object to the byte array, we just call the method toByteArray. But we have to convert somehow our user object to the this Protobuf user object. It is usually done just by hand. You set all the fields. Yeah, you create a new builder. Then you call set ID, set name, set other 50 fields that you have. Here in cycle, we say set all of the movies. So yeah, this conversion you have to write. Maybe there are some libraries that can do it via reflection, but from what I know, they are not that popular. And usually it's done by hand. And after we convert our user, we just call toByteArray. And then to deserialize, we parse from our serialized message, and we have our another user. And then we can convert it back to our normal another user with the same set of with the same process of just setting all the fields. Yeah, and I just understood that I removed the field ID and didn't understand why it didn't have set ID method. Okay, very dumb of me. And here we have our main method. We create this instance of this class. We serialize the object, print some information about it, deserialize it, so nothing new. Let's run it. Yeah, and we can see some binary representation in string. So again, we can see all the strings that were saved to the object, but we don't see any numbers here. So the format is binary. You don't see much data here. This serialized message takes 70 bytes. So here it's equal to the message pack. And the deserialized user, it works, it deserialized all the fields. Yeah, usually when you use a Protobuf on your project, you have only one schema. So for example, you will have this user.proto schema. It will be committed to another repository, and then your Java code and maybe, I don't know, Python code will use this schema to generate the respective classes. I have two schemas for another reason. Here I simulate the process of changing the schema over time. So I use one schema to serialize message and like another iteration of the schema to deserialize it back. Yeah, and usually you have only one schema. And let's see what happens if we change the schema. Let's, for example, remove the field ID. Let's see how the Protobuf breaks. For that, we have to generate proto again, so it will recreate the objects. And we go here, and we see that something doesn't compile. Okay, our another user deserialized. Another user doesn't have get ID field. We removed it from schema, and it was removed from the object. Okay, if we go back to schema and let's say add integer age, and the number of this field will be 4, and we will just increment the number of fields. It's okay. And we, oh my god, yeah, we go back to this class. Yeah, we don't have get ID method. We can call here get age. We have this field, but if you set ID to an age, it's, well, your fault. It's not a Protobuf didn't break, it's you broke it. And actually, let's try to run it. And we can see another user ID equals 0. So it's even now it didn't broke because in our another user.proto we have field age, it's number 4. So the Protobuf understands that it's not the same field as ID, even if we put it like here. And that's why here user get age doesn't return anything. We didn't store age, so we cannot restore age here. So the Protobuf is much more secure than the MessagePack. Here, it doesn't allow you to break your code that easily. Probably that's it what I wanted to show you. Let's discuss some pros and cons of the Protobuf. It has a high performance. It outperforms JSON very easily. It's like several times faster. A small message size. In our case, it was 70 bytes versus 121 in JSON. It is strongly typed, so you generate code from the schema, and if you wrote that this field is integer, you cannot save string here, and you can do it in the JSON, for example. And it's platform and language independent. So you can write the same schema for your Java backend, Python backend, JavaScript frontend, and all other languages too. And it's backward and forward compatible. So if you, as we have seen, if you write a message with one schema and try to read it with the updated schema, it doesn't break. It just doesn't read all the fields, so it works well here. But there are some disadvantages. It's more complex than the JSON or XML. Because you have to at least study like a syntax for these serialization formats. We just don't have any kind of syntax for JSON, XML, whatever. It requires additional tools. For example, to generate the code, we need a new Gradle plugin. It's not human readable, as well as other binary formats, and it has limited community support, especially compared to the JSON. So we have seen 4 formats. Let's try to compare them between each other. So first, the message size and the overhead. The payload size, as you remember, we calculated it to be 62 bytes. So the overhead for the JSON and BSON was somewhere around 100%, and MessagePack and Protobuf was 13%. So it's like much more efficient. But we can also compare it using other characteristics as well. Oh my god, I pressed it. Yeah. Let's compare them by readability, performance, message size, and evolvability. I don't say that these are like the only characteristics that we can compare them by, just I selected these characteristics. So the readability, JSON gets plus and everything other gets minuses. They are binary formats, it's very difficult to read it. Performance, JSON and BSON, they are okay, they're not very slow, but the MessagePack and Protobuf are much faster. Message size, the same. JSON and BSON, they have a huge overhead, especially in some cases, it can be hundreds of percent. And MessagePack and Protobuf, they're very, very efficient. If your integers can fit within 1 byte, not 4 bytes, it will try to store it that way. And the evolvability, JSON and BSON get plus from me, MessagePack gets minus, and Protobuf gets plus and minus, because you have to do something to evolve the schema, you have to commit it somewhere, so it's not that easy. And the point of this slide is not to urge you to use only JSON or only Protobuf. I just wanted to show you that each serialization format has its pros and cons. And well, actually, the advantages of each format can be derived from its disadvantages. So the JSON is readable, so we have to store the field names, so the message size will be very big. The Protobuf will be super performant, it will be very compact, so we cannot store the field names, and the readability will be lacking. So here, if you develop your own serialization format, you just have a lot of trade-offs to take. And it goes not only for the serialization, but for everything in computers, in programming, everything. If you develop a database, would you like it to respond faster or be more consistent? Should it be available if some nodes fail, or should it be more consistent again? So don't select the tool just because it's cool or modern. Verify all the opportunities and choose what is best for you. That's it from my side, and maybe at least now we have any questions.
Yeah, we have some questions. One question came from We Are Community. Let me post it here for you. And the question is, what about markup languages? Are they out of table now, min XML?
Yeah, there are like hundreds of serialization formats. I just selected 4 that seemed quite not similar for me, so we can see some trade-offs taken here. XML is a good choice in some cases, but well, it's not ideal too. And yeah, I just decided not to talk about it today.
Okay, I hope that answers the question. And the next one is, can we assume that Protobuf is better only for inter-service communication within microservices?
I think no. We used, on my previous project, we used Protobuf with a database. So we used Redis as a database. It's just to remind you, it's a key value store. The Redis doesn't understand what you put to it. It can be a JSON or Protobuf or whatever. And we selected Protobuf because it's very fast and compact. But yeah, it totally depends on your use case. I can think of use cases when communicating to the third-party service can be done with the Protobuf, and it would be the best choice. But yeah, I hope it answers. So the answer is no, it can be better in some other cases for other use cases too.
Okay, thank you. I assume there are no questions for now. We answered everything. So thank you for your light talk, and thanks everyone who joined and who asked us the questions.
Yeah, Thanks. I will post the link to the code and the presentation to the comments. Soon you will be able to play around with it. And actually in the code I have samples with the Avro format that is commonly used with the Kafka messaging system. And there are some benchmarks if you would like to take a look at them too. And a small announcement, we will skip the light talk on the next week. So we will see you in 2 weeks. Thanks for joining us today. Bye.
Thank you. Bye.